Today's lesson is a pretty simple one on the mean value theorem. This is a pretty intuitive theorem, but I'm going to go ahead and have you read this definition along with me, then pause the video and write the definition down. So this is exactly what the mean value theorem in calculus says. If a function is continuous on the closed interval a to b, where a is less than b, and differentiable on the open interval a to b, then there exists a point C in between a and b such that f prime of c equals f of b minus f of a all over b minus a. So pause the video and jot that formula down into your notebook and the words that go with it. Okay, now that you have the actual theorem written down, I'm going to bring it to life with a visual, which I often do. So here's the visual of the theorem. What I'll have you do, again, if you need to pause the video to do so, just write the word visual and draw me an x-axis and a y-axis. On the x-axis, we're going to kind of section off a piece of it and from A to B. And I'm just kind of drawing a generic curve here. I love this generic curve to use when I'm demonstrating different things like I did with the PQ graph back in chapter 3. Okay, so if this graph here is the graph of f of x, y equals f of x, and this is x, then these points, A and B, would have the following coordinates. I'm going to call the coordinates at A, comma, f of A, and the coordinates at B, b, comma, the function evaluated at that x value of b. So there are my coordinates. Now, if you remember from chapter 3, one of the things we did is we drew a secant line. So I'm going to draw a secant line connecting these dots at A and B. So that secant line is going to look like this. And the slope of that secant line, which back in chapter 3 we denoted as slope of the secant, that's going to be y sub 2, which is f of b, minus y sub 1, which is f of a, all over x sub 2, which is b, minus x sub 1, which is a. So this here is going to give me the slope of the secant line. It's also going to give me my average velocity. If this is a position graph, we talked about that also in chapter 3. Average velocity, because slope is rise over run, so something like miles per hour. So this is on average how quickly maybe an object or a particle or a car or a bike or a person is moving. Okay, so that's sort of half of the mean value theorem. So if you look back at your definition, let me just do a switcheroo. What I just showed you is this part of the theorem. Okay, so this is the average rate of change on the interval A to B. Okay? Now, what about this side with the f prime of c? Okay, well, let's go back to the drawing. What the mean value theorem says is that as long as your function is both continuous and differentiable, so there's nothing weird going on, no discontinuities, no holes, no vertical asymptotes, no vertical tangents, no jumps, no corners, as long as everything's kind of smooth sailing between A and B, then the theorem says that you can catch a point C that sits in between A and B, where if you come up to the curve and draw a tangent line, the two lines will be parallel, meaning have the same rate of change or the same slope. So the slope of the tangent line at C, f of c, is what we call f prime of c. Slope of the tangent line is the derivative. So the mean value theorem says that at the point C, these two are going to be equal, and that's where we have f prime of c equals f of b minus f of a all over b minus a. And that's all there is to it. That's how simple this theorem really is. Now in words, this is what I'm going to have us write down. In words, what I would say is, at some point on a time interval, the slope of the tangent line at C will equal the slope of the secant line between A and B. You can pause this and write that down. When you come back, if I put this sort of into a real-world context, just think of driving a car. If you average a certain speed on a time interval, say you're averaging, you take a 3-hour trip in your car, and you average 60 miles per hour over that 3-hour period, that means that at some point during your trip, you had to have been going 60 miles an hour. You can't average 60 miles an hour without being under it and over it, or going it the whole time. So that's sort of like the real-world application of the mean value theorem. It's that simple. Okay, so as far as practice problems go, you have 2 worksheets with you. The first one says mean value theorem review. And so this was just meant to be some practice using it. So the first one is really just multiple choice, asking you to pick the theorem out again. So if you read this and look at your answer choices, you're going to see the mean value theorem right here in letter D. F prime of C equals f of b minus f of a over b minus a. So hopefully if you looked at this already, you already chose letter D. Let's move down to number 2, because this is the first time you're going to actually be doing a problem with the mean value theorem. It says, what is the value of C that satisfies the mean value theorem for the function given below on the specified interval? So here's what we have. We have f of x equals x squared minus 2x on the interval from 2 to 4. So the first thing I'd like you to do is, let's call this A and let's call this B. And what I like to do is just set the theorem right up. So the theorem says, I'm going to copy it from letter D up here, f prime of C equals f of b minus f of a all over b minus a. And all I have to do is find the components of this formula. So let's work left to right. So f prime when x is c. Well, the first thing I'll do is I'm going to come off to the side here, and let me just find f prime of x. That's just a simple derivative. So f prime of x is the derivative of x squared minus 2x, which is just 2x minus 2. But the formula doesn't want f prime of x, it wants f prime of c. So that's simple. F prime of c is just 2c minus 2. So this is what I'm going to put right here. 2c minus 2 equals. Okay, now I'm going to find my f of b and my f of a. So since b is 4, I'm going to have to find f of 4. So f of 4 will be 4 squared minus 2 times 4. Just plugging into the original function. And that is 16 minus 8, which is 8. So I'm going to put that here. Minus. Now I have to find f of a. Well, a is 2. So f of 2 is 2 squared minus 2 times 2, which is 4 minus 4, or 0. Okay, so I'm going to put that for f of a. And then this is all over b minus a, so 4 minus 2 is 2. Then all that's left is to take this part of your theorem and solve for c. That's what they wanted. What is the value of c? So 8 minus 0 divided by 2 is just 4. So coming over this way, I have 2c minus 2 equals 4. Then I can add 2 to both sides, which will give me 2c equals 6. And then I can divide by 2 to get c equals 3. So the answer to this first part, number 2, is c equals 3. Okay, that's not difficult at all. It's mostly just algebra 1 besides taking that derivative over here. Okay, and then number 3 says, using only a graphic or a graph, explain what this answer means or what it represents. So what we're going to do is we're going to go ahead and graph f of x. So let's start with what f of x was. F of x is x squared minus 2x. Now it is quadratic, so it'd be pretty easy to graph this guy. We can find the y-intercept by evaluating f of 0, That would be 0 squared minus 2 times 0, or 0. So we have a y-intercept of 0, 0. We can find the x-intercepts by setting the whole darn function equal to 0. I can factor out an x. I'm left with x minus 2. When I set both of these to 0, I get x equals 0 or x equals 2. I can find my vertex by using the formula x equals the opposite of b over 2a. So the opposite of b is positive 2 divided by 2 times 1 here. 2 times 1 is 2, so my x-coordinate of the vertex is 1. To find the y value, I just plug 1 back in. 1 squared minus 2 times 1 is negative 1. So I have a vertex at 1, negative 1. So, putting this onto a graph, remember I'm supposed to be getting a graphic here. Here's x, here's f of x. I've got 0, 0 as my y-intercept. I've got 0, 0 and 2, 0 as my x-intercepts. I've got 1, negative 1 as my vertex. So this graph is just going to kind of come through here, hit the vertex, and then sail on its way. Now, I need to zone off the area here between x equals 2 and 4, because let's not forget our interval here was 2 to 4. So I'm going to come up here, and here's 2. If I come out here to 4, go a little bit higher on my graph here, maybe about right here. And if I draw the secant line connecting 2 to 4, I would have this. Okay? So what we're saying here, when we say c equals 3, what we're saying is that if we go to x equals 3, if we come up to the curve and draw a tangent line there, that tangent line is going to be parallel to the secant line that's joining x equals 2 and x equals 4, which visually it looks pretty good, even though we're doing this freehand. That does look like they're parallel. So that's really all there is to the mean value theorem. So what you're going to do for homework is working on this sheet, the practice problems. And for each one of these, you're doing the same thing. You're just setting it up, and you're finding the value of c within these boundaries, a to b, where the mean value theorem holds true. All right, mean value theorem, there you have it.